Solar storms, also known as space weather events, are real and potentially catastrophic phenomena driven by the sun's activity. These events stem from solar flares, massive bursts of radiation, and coronal mass ejections, or CMEs. CMEs are the real danger. When the sun expels billions of tons of charged particles at high speed, those particles can crash into Earth's magnetic field. Normally, Earth's magnetosphere protects us. It bends and redirects the storm, channeling the particles toward the poles. That's what creates the beautiful auroras, the northern and southern lights. But when a CME is particularly large and magnetically aligned just right, it can overwhelm the magnetosphere and essentially punch through our defenses. Once that happens, the damage isn't from the particles themselves. It's from what they do to our technology. Welcome to Parallel, a mix of storytelling and thought-provoking what-if scenarios, combining narrative fiction and analysis that includes real-world science, philosophy, and potential real-world implications. Don't forget to subscribe, like, and comment so that you do not miss out on the next episode. Because, one reality, sasti boom, is never enough.
That can't be right. X9.3. Again? That's the third one today. Magnetic fields reversed. Southward. That means it's going to couple. It's going to punch straight through our magnetos. Let me look at the trajectory. No. 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 Full halo coronal mass ejection. It's coming straight at us. Estimated impact window, 72 hours. The grid's not ready. Not for this. Transformers will blow, satellites will fry. Planes, GPS, hospitals, offline. The entire planet's infrastructure, exposed. Cities will go dark. Not just for minutes, for weeks. We're not built for this. We've wired our whole world into a system that can't survive the sun sneezing. 3 days. That's all we have. 3 days until we see how fragile everything really is.
We've seen the sun do this before. The most infamous example? The Carrington Event of 1859. Back then, our world ran on telegraph wires and steam. But even with that primitive technology, the damage was staggering. Telegraph lines sparked and burst into flames. Operators received electrical shocks from their own machines. Auroras lit up the skies, as far south as the Caribbean. It was the biggest geomagnetic storm in recorded history. Now imagine that same energy hitting a world wired with satellites, microchips, and global power grids. In fact, it almost did. In 2012, a solar storm of similar magnitude just missed Earth by about a week. If it had hit, we would still be recovering today. Another close call came in 1989 when a much smaller CME knocked out power to 6 million people in Quebec. In just 90 seconds, the entire province went dark. These aren't science fiction scenarios. These are warnings from our own sun. Today, with satellites, GPS, smartphones, internet servers, air traffic control, electric grids, and financial networks, our vulnerability has multiplied exponentially. Modern society runs on a digital bloodstream, and solar storms are capable of wiping that out, all in a matter of hours. What would happen if a solar storm hit major cities? Let's fast forward. A massive CME, one comparable or larger than the Carrington Event, is inbound. Here's what happens next. First, satellites go dark. Communications are lost. GPS starts to fail, misguiding planes and ships. Weather forecasting vanishes. Internet and mobile networks become unstable. Then, geomagnetically induced currents, or GICs, begin to flow through long conductors, like the massive power lines that span continents. Transformers overheat and explode. Electrical substations catch fire. Entire power grids collapse, not just in one city, but across entire regions. New York, London, Tokyo, Mumbai. Modern megacities plunge into darkness. Subways stop, elevators trap people, water treatment systems fail, supply chains grind to a halt, hospitals lose backup systems after batteries drain, ATMs go dark, digital banking becomes inaccessible. What's terrifying is that the damage isn't just temporary. Many of the giant transformers used in national grids are custom built, and they take months or even years to replace. This means power may not return for weeks, even in the best prepared cities. And the economic fallout? Trillions of dollars. But even more critically, people's lives are at stake. In a single week, we could find ourselves back in a pre-electric world. In the aftermath, society would be forced to reorganize quickly. People would flee from cities to find power, water, and food. Governments would have to ration supplies and enact martial law to prevent looting and panic. Hospitals and emergency responders would operate in the dark, or not at all. Agriculture would suffer too. Many modern farms rely on GPS and automated systems. Refrigeration would fail. Crops could rot. Food distribution, now completely dependent on electric logistics, would fall apart. The internet, the backbone of modern communication, would be shattered. Even if some servers survived without the power grid, they're useless. Think of what happens when a city loses power for a few hours, like what happened in Portugal, Spain, and France earlier in 2025. Now imagine that on a global scale, for weeks. Would nations fall? Would the global economy collapse? That all depends on how well we're prepared. Now, could we survive the next one? Here's the good news. We're not completely helpless. NASA and the National Oceanic and Atmospheric Administration run space weather monitoring systems like the Solar and Heliospheric Observatory and the Deep Space Climate Observatory. These provide us with some warning, usually 12 to 72 hours before a CME hits Earth. Although the recent defunding of some of these agencies by the Trump administration in 2025 could leave us dangerously exposed, but it's in the preparation part. That's where we really fall short. Right now, most power grids aren't hardened against GICs. Transformers don't have enough shielding. Satellites aren't equipped with fail-safes for sustained radiation. And public awareness is almost non-existent. Some countries, like Canada and parts of Scandinavia, have started investing in mitigation technologies. There are plans to ground power lines, isolate transformers, and create emergency satellite redundancies. But it's not enough. Not yet. The cost of preventing catastrophe is a fraction of the cost of repairing one. But until the world treats space weather with the seriousness of climate change or cyber warfare, we remain vulnerable. We think of natural disasters as storms, floods, and earthquakes. But solar storms are different. They are invisible until they arrive. They don't destroy with wind or fire, they erase systems. They erase infrastructure. What's most chilling is how fragile modern life is. The conveniences we take for granted, light, water, communication, healthcare, are all just a solar sneeze away from collapse. And yet, this isn't fear-mongering. It's a wake-up call. With enough foresight, investment, and education, we can prepare. We can insulate power grids, Train for blackouts. Build offline redundancies. Rethink how much of our world depends on a single point of failure, because the sun will storm again. That much is guaranteed. The only question is, will we be ready when it does? Thank you so much for listening in to this episode of Parallel. If you have an idea for a future episode, drop it in the comments below. Don't forget to like and subscribe, as it really does help the channel grow its audience. Until the next episode, remember, one reality is never enough.